around now. Let's try again. All right, so this is what we're looking at. pH, pOH, these symbols here and this symbol. First thing I want you to do is to find the log key. This is going to be very important in your calculator. Every calculator has one. On this calculator, it's right there. Okay, on this calculator, it's right there. Expensive calculator. Okay, oh yeah, it's going to jump around on me again. Gracious alive. Okay. So let's see, where's log on this one? There's the log button right there. Okay. Every calculator has one.
You want us to press it?
No, I just want you to find it. Okay. Now, here's why. In our last unit, we learned about molarity. Okay, remember molarity? Molar concentration is the moles of solute divided by liters of solution. Okay? pH is based on this. Okay? Now, in an acid solution, the symbol we use for the molar concentration of the hydrogen ion is that hydrogen ion in brackets. And that simply stands for the molar concentration of the hydrogen ion. The molar concentration of the hydrogen ion. Okay. So this up here is the molar concentration we're talking about here. And we learned all about that in Unit 8. All right? Now we're going to apply that to acids. Now, pH is negative logarithm base 10, which is what that LOG button on most calculators is all about, of the hydrogen ion concentration. Now, if you remember from earlier in the week, we used the Arrhenius system for dissociating acids, and we also used a Bronsted-Lowry system for dissociating acids. In the Arrhenius, one of the products was always this H+. Okay, in Bronsted-Lowry, the product was always H3O+. Okay, and the amount of them is the same. It's just a different way of thinking about what happens to those hydrogen ions. So the pH is also then the negative logarithm, and negative meaning change of sign, of this hydronium ion concentration. H3O is a special ion we call hydronium. Okay? So if the molar concentration of H3O plus is 0.0125, what is the pH? Okay, so you need to get out your calculator.
Is that an M?
Yeah, M with a line under it. Now, if you have an inexpensive calculator, you're going to have to do this calculation backwards. Okay? And you have to figure out whether your calculator is one that will do it forwards or backwards. I don't know. Let's find out. We're going to, if it does it forwards, you put it in just the way it reads here. Okay? So pH then, for this equation, or this problem, let's do pH is equal to the negative logarithm. of this concentration of hydrogen ions or hydronium ions. So negative logarithm of 0.0125. Okay? So I'm going to put it in, on this calculator, I'm going to put it in just the way it reads. Okay? I'm going to hit my change of sign button. Now, a subtraction button is different from change of sign. This is a subtraction button here. This is a change of sign button over here. Okay? So I'm going to put in negative logarithm. I'm going to put in the change of sign button. Okay, I want to hit the logarithm button on my calculator. Now, my calculator, because it's a little more high-end, I've got to put in a base of 10 here. Most of your calculators won't have to, unless you have one of these TI Inspires. When you hit LOG, that already has a base of 10. Okay? And then you're going to just simply put in this number, 0.0125, and hit enter. All right. On your calculator, find your change of sign button. Anything that changes the sign. Sometimes it's a negative sign in parentheses. Sometimes it's a plus, / minus button. But it's not the same thing as your subtraction button. Okay? Hit your change of sign button. You need to listen to me. Hit your change of sign button. Press your LOG button. You need to put the number in parentheses. Some calculators do the parentheses for you. Some don't. So you need to put your number in parentheses. See how it's put in parentheses here on my calculator? The number's in parentheses. Put the number in parentheses. Close the parentheses and hit enter. If you don't get the same answer as me, okay, then you're going to have to do your calculations backwards.
Yeah, I didn't do nothing like that.
Okay? Then you're going to have to do your calculations backwards.
I got it right.
You need to know whether your calculator will do the calculations forwards or backwards. You need to learn to talk your calculator's language. Is that clear to everybody?
It doesn't talk.
Get a Rosetta song for that.
Oh, it talks. You might not know it's
I
talking.
can't hear it.
Yeah, you know what? You can't hear deaf people talk either, but they're still talking.
Oh.
Okay? All right. Shh. Now, if your calculator doesn't give you this answer, you're probably going to have to back into it. Put it in backwards. So what you're going to do is do this. Clear your calculator. If you didn't get that answer, clear your calculator a minute. All right? Put in the number first. Put in the number first. 0.0125. Okay? Now find your log key and hit that. Okay?
Yeah.
Now hit your change of sign button. Hmm?
What am I changing this time?
This is your change of sign button down here.
Alright.
Okay? So you've got pretty much everything right here, except you just got to hit the change of sign button. Let's see if I can get on the screen so everybody can see it here. So you've got the number basically that's a negative at the moment. All we have to do is go down here to the bottom where it says plus, arrow, minus, and hit that button, and that's going to change your sign, and that gives you what you need. Okay? All right. Did everybody manage to get the correct answer? All right. All right, now listen. Write down the full answer your calculator gives you. Okay. Now, there are no units of measurement in a logarithm because a logarithm is an exponent. Okay? A logarithm is an exponent on the number 10. That's a definition you need to know. A logarithm is an exponent on the number 10. Okay? And I'll show you what that means in a moment. Okay. Now, we'll get back to that, but right now I want to show you how to round this off. There is a special rule for rounding when you're using exponents and logarithms. we are not going to learn a new rule for rounding. Okay? So if I have to have this many significant digits here, I need to have an answer with that many significant digits. We're going to use the multiplication division rule. There are 3 total significant digits in this number because leading zeros are not significant. Okay? So I need 3 digits in this answer. And the way we do that is to underline everything but those 3 significant digits and draw an arrow to show that we're rounding off. And this is an operator that actually shows we're rounding off. It has to be there. And then we show the rounded off answer. So the 3 here is less than 5. It doesn't change the 0, so it's the pH is 1. The predicted pH is 1.90. Okay? Got that? All right. I want to go back to what I said a moment ago about logarithms being exponents, huh?
Log.
L-O-G.
Well, just remember LOG. Yeah.
It just sounds like it's spelled different from what it says.
Yeah, kind of like it sounds. It's kind of like it's, yeah. Just remember LOG, okay? That's all we need to do here. All right. Let's just do this for practice, all right? I want you to take the logarithm of 10 to the 3rd power. Take the logarithm of 10 to the 3rd power. What'd you get? Okay. Now let's take the logarithm of 10 to the minus 5 power. Remember, your minus 5 needs to be the change of sign, not a subtraction key. What answer did you get? Okay, so the exponent is the logarithm on the 10. The exponent of the 10 is the logarithm. See what I'm talking about? Now the reason we get these really long numbers like we did before is because if this had been just a 1 here, our answer would have been a 2. Because we wrote this as a 10 to some power, it'd be 10 to the negative 2. Okay, and we changed the sign here, that's why it would have been a 2. Alright? And the reason we use logarithms is because it helps us with really, really large numbers to kind of keep in mind what's going on. Okay, so measuring the amount of acidity of a solution is a lot easier using pH. It's easier to recognize and understand than using the actual concentration units, because the actual concentration can be really, really small. Got a lot of zeros, or 10 to the negative 9 or something. And so what we want to do is to try to make it a little bit simpler, and that's what pH is all about. Okay? All right, do we want to practice calculating pH one more time?
Sure.
All right, let's do one more. Okay, if the concentration of hydrogen ions in a solution is 1.47 times 10 to the negative 4 molar, what is the pH? Now you have to show all your work, which means you have to put it down like this, okay? You have to put all your work on paper. Hey, you know what? This is a lot easier than what I had to do when I was in high school. We had to use slide rules.
Why y'all do that?
Do we got to put the negative? Not for negative 4.
Yeah, it won't be right without the negative 4.
No, I know that. I'm not negative. Wow.
You have to take the negative logarithm of this number to get the correct answer.